Yeah.
Assalamualaikum. My name is Ahmad Firdaus. This is my group members, ALIAH AFIFAH and AMALIZA. We are from group 8. So for this lab 2 and title Coulomb's Law, we are gonna make a simulation about the charge 1 and 2. Okay, first we go into the software on the website. For the first data, charge 1 is -6 microcoulomb and charge 2 is -8 coulomb, and the distance is 2 centimeter. So from here we will record the value, which is the force on both 1 on 2 and 2 on 1 is 1.08 times 10 power of 3 Newton, and the force is the repulsive force, and the measured value of force is 1080 Newton. So this one is the repulse. Next, I will simulate the attract force. So I will take the third data, which is charge 1 is -7 microcoulomb, and charge 2 is 9 microcoulomb, and the distance is also 2 centimeter. So the force on both on 1 on 2 and 2 on 1 is 1.42 times 10 power of 3 Newton, and the measured of the force is 140220. Okay, and next for the remainder of the parameter, we have already screenshot. So this is the parameter, others parameter, and all of it has been recorded on this table, on the table 1. Okay, next I will pass to Anis Amaliza to present the next.
Okay, so by the experiment, we can conclude that when the charge is same, it will repulse. Meanwhile, when the charge is different, it will attract. Okay, so the evidence that we see in when when one body interact with another exacting force on each other that equal in magnitude and opposite in direction. From this, we can see that the Newton third law apply to the electrostatic force. Okay, so for the 4.4, how does the value of the electrostatic force vary with the value of the change? Okay, this one. Electrostatic force between two charged particle is directly proportional to the value of charged particle. Okay, so for 4.5, how does the value of electrostatic force vary with distance between them? In electrostatic, the force between two charged objects is inversely related to the distance of separation between two objects. Increasing the separation distance between objects decrease the force of attraction and or repulsive between the object. Okay. So next, ALIAH will continue.
Okay. For 4.6, the question asks us to use measurement from data in table 1. Okay, and determine Coulomb's constant for at least two situations. So I pick two situations, which is scroll bawah sikit. Okay, so we used to charge 8 micro and 5 micro. So we substitute the value and we get K. So the value of the K is 9 times 10 to the power of 9, which is that is the constant value of the electrostatic force. Okay. Next, determine the electrostatic force of negative 4 coulomb charge, which is 3 centimeter from a 5 microcoulomb charge. So we substitute the value. So Q1 is negative 4 and Q2 is 5. And then distance is 3 centimeter. Change to SI unit. So it's become 0.03 meter. And then we got the force is 200 Newton. Why actually the force cannot become negative? Because there is absolute apa?
Modulus.
Modulus. Modulus in the formula. All right. Next. Okay, next question is electron has a charge of negative 1.6 to the power of negative 19 and a proton charge. So we substitute the value as well. So we got also force which is 82.02 nanonewton. Next is, okay. So this question asks us to measure, scroll atas sikit. Okay, so this question asks us to measure value of electrostatic force for all charge in table 1. So this is all the force that been calculated, and we compare the result between the simulation and calculation. So the result is quite similar. All right, next. So in conclusion, we are able to determine what makes a force attractive or repulsive and able to relate the electrostatic force magnitude to the charge and the distance between them. Uh, in this lab also, we explain the Newton's law for electrostatic force and use the correct measurement to determine Coulomb's law. So that's all from us. Thank you.
Thank you.